Hello, in this video we will see a DIY home automation project. In this project we will see how to control home appliances using ESP Rainmaker app, Google Assistant, Alexa, IR remote, RF remote and also via manual switches. So, without wasting more time, let's get started and see the circuit diagram of the project. Here is the circuit diagram of the project. So, you can see, all wiring connections are in color coding and properly commented. Hence, you can easily track them and replicate on your desk. So, you can see, we have interface TSOP1738 IR receiver, for 33 MHz RF receiver module, 8 manual switch buttons and 8-channel relay board with the ESP32 dev board. 8 AC bulbs are connected to the relay module. You will get this schematic on our GitHub page. Links will be shared in the video description. This is high-resolution image, you can zoom it further if you want for more detailing about connections. For IR receiver, you can use any of these two components. This is SM0038 IR receiver. And this is TSOP1738. Please note that both IR receivers have different pinouts, please connect with caution. Since SM0038 has VS or VCC or power supply pin is at middle section. You can see here. Whereas for TSOP1738, middle pin is a ground pin. You can see the pinout difference in these diagrams. So, be cautious and connect according to your receiver's pinout. Connecting wrong pins to power or ground may cause damage to the component. So take care while connecting. This is the RF receiver module we have used. For RF receiver, you can use this type of 433 MHz RF receiver module. And this type of 8-channel 433 MHz RF remote. Most importantly, please note that, this project demonstrates the control of AC bulbs that operate on 230 volts AC. Therefore, to avoid any high-voltage electric shock, fire and burns, it is advisable to take proper precautions if you plan to replicate this project on your desk. Students and minors are strictly advised to work under proper supervision and guidance. Use personal protective equipment, PPE kits and insulation. This is all about hardware, now let's see the software or code of the project. So, here is the code. You can see, all code is well commented. We have added detailed comments to each important code snippet, functions, and subroutines, to guide you through these code implementations. We have added comments for each section of the program, to easily understand, for what purpose that code snippet is used there. Therefore, you can understand, what's going on with these functions and variables. In that context, let me show you the important points which you must know if you wish to replicate this project on your desk. You just need to replace these IR and RF codes of your remotes, here in these sections. These are codes specific to IR and RF remotes which we are going to use. You have to find the IR and RF code specific to your remotes. So, how you can do that? Let me show you. For that, you have to first connect or interface your IR receiver, either SM0038, or TSOP1738 with ESP32, like shown in here in circuit diagram. You will get this circuit diagram on GitHub repo of this project. Then, open this program which also will be given to you on same repository. You just need to connect your IR receiver with your ESP32 as per the circuit diagram, and then open this program in Arduino IDE. Select your board and COM port. Then upload the program into your ESP32. Once program get uploaded, open serial monitor of Arduino IDE. Just follow along as shown in this insight video. You have to point your IR remote towards IR receiver, and press the buttons one by one. As soon as you press any button, its related IR code will get decoded and printed out on serial monitor. Likewise, note down decoded codes for each button. And find all 8 buttons codes for your IR remote. These will be the IR codes for 8 buttons which you have to put into main program. Let me show you. Here you have to replace all your IR codes. You have to replace these all codes for all the buttons which you wish to use, and available on your IR remote. Okay, this was all for IR remote. Now, let's see how we can get codes for our RF remote. For that, again you have to first connect, or interface your RF receiver and ESP32 like shown in here in circuit diagram. You will get this circuit diagram on GitHub repo of this project. Then open this program which also will be given to you on same repository of project. You just need to connect your RF receiver with your ESP32 as per the circuit diagram, and then open this program in Arduino IDE. Select your board, and serial COM port. Then upload the program into your ESP32. Once program get uploaded, open serial monitor of Arduino IDE. Just follow along as shown in this insight video. You have to point your RF remote towards 433 MHz RF receiver module, and press the buttons one by one. As soon as you press any button, its related RF code will get decoded and printed on serial monitor. Likewise, note down the decoded codes for each button. And find 8 buttons codes for your RF remote. These will be the RF codes for 8 buttons which you have to put into the main program. Here is another program for testing, where we have placed RF specific codes of each button into this switch case block of this program. Now let's upload the program, and see our buttons are getting identified or not. So, you can see, as we press any of the button, serial monitor prints and shows which button is pressed. So, we have now got the RF codes for our remote. Let's put these into our main program. Let me show you. Here you have to replace all your codes. And that's it. So, in this way you can find out all IR and RF codes specific to your remotes, and replace them here in main program. For Rainmaker projects, there is one important setting you have to do in Arduino IDE, which is selecting Rainmaker partitioning scheme for ESP32 board. So, let me show you how you can do that. First, open Arduino IDE and your Rainmaker project sketch. Here is our sketch. Now to change the partitioning scheme, we have to go to this top left menu of Arduino IDE. Here, select Tools option. In Tools option drop-down submenu you will see several settings, like your board type, the serial COM port, CPU frequency, flash frequency, and so on. So here, please go to option of partition scheme. Okay? This one. Partition scheme. And by going down here in this option you will see several partition schemes supported by your ESP32 board. Like default ones, OTA, Huge Apps, SPFFS, etc. Here you will find this partition scheme named Rainmaker. This one. You have to select it for your ESP Rainmaker based project for your ESP32 board. Click on it to select it. You can verify it again whether the partition scheme got correctly selected or not. You can do that by going into Tools menu again. Okay? Like this. Now once you set your Rainmaker partitioning scheme, you can go ahead and compile, or upload the sketch into your project. Alright, in this way you can select Rainmaker partitioning scheme in Arduino IDE. Now you can upload the program into your ESP32. Just remember that this program is created for circuit diagram we have shown earlier. So, all pin connections are as per circuit diagram given. If you want to modify the circuit diagram or program, you have to make changes in subsequent document. Now let me show you how you can add voice assistant service to your project. For that, in your phone, first let's open ESP Rainmaker app. Here in app, on bottom right corner there is settings option given with gear icon. Click on that to go into settings. Here in settings, you will find your account specific options, like notifications and email. Among which one option is voice services. Click on that. On next page you will see supported voice services like Amazon Alexa and Google Assistant. Let's click on Amazon Alexa to connect it with ESP Rainmaker. So, you can see, we have already linked our Rainmaker account and devices with Alexa. You have to link here with link button. It's pretty simple process. Now let's get back and see how to add Google Assistant. Click onto its option. It will open web page of Espressif, which will show instructions about how to enable Google Voice Assistant. You can pause and read it. Follow the instructions carefully and stepwise. Let's get back and let me show you our Google Home app setting about ESP Rainmaker. So here is the Google Home app. Here, you have to go to Devices tab. And as they have instructed, click on plus icon to add Rainmaker device. On next page, here you have to choose device that is labeled as Works with Google Home option. Now here you can link your ESP Rainmaker app. If Rainmaker service is not showing, you can search it with search bar option. So, we have already linked it, hence it is showing as ESP Rainmaker with one device. You can see there are several other services also. If you click on ESP Rainmaker icon, it will start connecting. We have already got it connected, hence it is showing reconnect or unlink. So, in this way you can connect or link the voice assistant services to your project. Okay, now let's see the practical demo of this project. So, this is complete assembly of the project. We have connected all the components as per the circuit diagram. Now we will see all the components included, and how they are connected with each other. So, first let's see the brain of the project, Node MCU ESP32 development board, which is then interfaced with this RF receiver module. For 33 MHz RF receiver module. Then this is a ESP 1738 IR receiver module. Then next is the 8-channel relay module. This side is DC side. And other side is AC side. So here we have connected 8 light bulbs. You can see all 8 bulbs here. We have powered this relay module with 5 volts external power supply, given from power bank. Then here is the manual switch board which consists of 8 buttons. These are connected to the GPIO pins of ESP32 development board. Then here is the IR remote with infrared transmitter LED. This will be used to send commands to this ESP IR receiver. Then this is the RF remote, which we have going to use for this RF receiver module. Then for IoT part, we have also installed ESP Rainmaker app in our phone. Also, there are Amazon Alexa and Google Home apps. And here you can see, the smart speaker, the Alexa Echo Dot. And that's it. This is all circuitry and assembly. You can refer the circuit diagram given on project repository for more details. Now let's power on this circuitry, and see the demo. So, you can see, as soon as we provide power, ESP32 turns on, with red light on. There is this blue LED which shows that Wi-Fi is available and connected. Okay, so, now circuit is powered. So first, let's see manual switch control. Oh yes. We haven't given power to relay module. We also need to give power to relay module. Now we have power on all circuitry. Let's see the demo of switch buttons. So you can see, we can turn on and turn off the light bulbs using these switch buttons. Please note that, for the time being, and for demo purpose, we have connected only AC bulbs. But one can connect AC appliances like TV, fan, motor, heater etc. to these relays. And we can control them manually using these buttons like we do in daily life in households. Please note that, we have programmed this project in such a way that, this switch control method will work even if the Wi-Fi is unavailable. Okay, so this was all about switch-based control. Now let's see the IR remote-based control. So this is an IR remote, means infrared remote control. This is similar like typical remote, which we used in our daily life to control the appliances like TV, music players etc. Here we have programmed IR codes of the 8 buttons on this remote, to control the bulbs. Let's test this. So, as we know, IR requires complete line of sight. So you have to point IR remote towards the IR receiver, and press the buttons on remote one by one to turn on and turn off the bulbs. We have also programmed all on and all off functions. You can see here. We can turn on all devices at once. Or you can turn them off. So, this feature of IR remote control also does not require Wi-Fi. It will work even if Wi-Fi is unavailable. So this was demo of IR remote, now let's see for RF remote. So this is a RF transmitter remote, and this is a RF receiver. Let's see how this works. So, you can see, we can turn on and turn off the light bulbs using this RF remote. Here, please note, this RF remote is not like an IR remote which require line of sight to work. But for RF remote, it is not necessary to point the remote in the direction of RF receiver. It has omnidirectional coverage. This remote will works over radio frequency. Hence, we can use and control the light bulbs from surrounding distance about say 5 to 10 meters approximate or even more. Additionally, this RF remote's control feature will also work without need of Wi-Fi or internet connectivity. So, this was all about RF remote control. Now let's see demo of IoT part. That is, ESP Rainmaker app. For which it is mandatory that your smartphone and ESP32 must be connected to Wi-Fi and subsequently to the internet. So you can see, here is the ESP Rainmaker app on smartphone. Let's open it. So, these all are lights widgets here on the dashboard. We can use these to control all these bulbs. There are different names are given to each appliance according to floor plan of house. Like kitchen light, garden light, bathroom light etc. Let's use these switches one by one. So you can see their status also. In this way you can turn on and turn off the light bulbs or any other appliances like fan, TV, fridge etc. using this method. Let's see one more feature of ESP Rainmaker. Here, pay attention, if we are using these manual switch buttons to control the lights. The status of each bulb will also get reflected in ESP Rainmaker app, which shows that, is there any bulb turned on or off. You can see that here in demo. This is cool, isn't it? Same goes with IR and RF remote control method. If we change the status using remote, same will get reflected in app. Alright, now let's see the demo of voice assistant services. Means Amazon Alexa and Google Assistant services. Just follow along and see the demo.
Alexa, turn on kitchen light.
Okay.
Alexa, turn on hall light.
Okay.
Alexa, turn on bedroom light.
Okay.
Alexa, turn on lounge light.
Okay.
Alexa, turn on garden light.
Okay.
Alexa, turn on basement light.
Okay.
Alexa, turn off garden light.
Okay.
Alexa, turn off basement light.
Okay.
You can see, we can also control the appliances or lights using Alexa app, manually from app dashboard. So, this was all about demo of Amazon Alexa service. Now let's see Google Assistant demo. For that, open Google Home app. Here go to Devices tab. So here, you can see, all our lights devices got listed. Please note that, for the demo of Amazon Alexa and Google Assistant, you have to link the ESP Rainmaker to those voice services. We have covered that part already earlier in this video. So here, you can see, in Google Home app, we can also control the light bulbs manually from app itself. Moreover, we can also give voice commands to control the lights.
Okay Google, turn on all lights. Turn off all lights. Turn on bedroom light. एलेक्सा, गार्डन का लाइट ऑन करो।
ठीक है।
एलेक्सा, किचन का लाइट ऑन करो।
ठीक है।
एलेक्सा, बेडरूम का लाइट ऑन करो।
ठीक है।
टर्न ऑफ ऑल लाइट्स।
Okay, so in this way, we have seen a IoT-based home automation project, in which we have seen how to control home appliances using IR remote, RF remote, manual switches, ESP Rainmaker app, Google Home Voice Assistant and Amazon Alexa smart speaker. In future we will try to make more projects using this amazing platform of ESP Rainmaker. Stay tuned for more projects and tech updates. If you face any difficulty in replicating our DIY projects, feel free to ping us on Telegram or WhatsApp. You can also send us email at info@make2explore.com, we would be happy to help. Thank you.